Good morning, Year 10. I hope you're keeping yourselves well. It's Mr. Sutton here, and I'm going to be going over the task that we've got today. Now, normally it's our Unit 1. Been shaking it up a little bit this week just to try to give you a little bit more time, ease you in gently after the half term. And in that case, I'm really pleased with the people that have managed to, on Teams, get their bits and pieces sorted out as far as the assessments are going. So it might be a nice idea to have a look at that. Got Rowan's one up here, but I'll just pop back again because I thought, Rowan, you did a particularly good job of that one. I asked you to do the basic hand tools. So for those people that haven't done this one, I'm going to build on this today. We're going to be adding to this document and I'll be asking you to submit the whole thing. So we can see on here, Ella put hers in 12 hours late, but that's fine, Ella, don't worry about it as long as it's there. Rowan, you've got yours in. Chloe, you've got yours in. Daniel, you've got yours in. Dylan, you viewed it. Fletcher's not doing anything. Corbin has handed one in. Lydia has handed one in. Tommy has viewed it. And yet again, Tommy, not seeing anything coming up. Sam has turned one in. Sophie's not turned one in again. Jenna and Will have also done it. Teague, you haven't completed it yet. Callum, Amir, Harry and Nicholas, all of you have done one. So actually that was pretty good. That's actually one of the better amounts of people are really starting to pick up on these ones. Today I want you to add to that document. I thought I'll make it fairly easy for you on a Friday. I'm not going to do too much of a task. It's basically doing exactly the same. And you know what actually Rowan managed to do really, really well. If we look at his, I'll just give his as an example because I think it's really quite nice. Using this where you've got a nice simple image and then a description of what it does. That's really all I want because for your revision purposes, that's the most important thing for you to do. And we just need to add a few bits and pieces to that one today. Now, if you've got the textbook, this carries on from page, is it 110? Yes, 110 onwards, and I will put that into the notes. With tin snips, hacksaws, your files, but more importantly, tap and dies, which I'll come on to. I'm going to go through the tin snip fairly quickly because they're not that complex, really. And if you've got your book in here, you'll see that really, when we're talking about tin snips, they are scissors that cut metal. I mean, what does it say in the book? It says, tin snips are used to cut sheet metal by hand. There you go. These are larger guillotine-style shears for larger gauges. Really, they are just that. The size of these, I mean, these are quite nice, chunky ones with a spring-loaded action just there. They're used for cutting through metal sheet. And when I say sheet, we're talking nothing too thick. Once you get above like a 1.5 mil, 2 mil, they're going to struggle because the amount of force that you need to cut a sheet like that, especially with steel, is going to be very, very high. But it does allow you to rough up a piece of work, cut it out fairly roughly, but it can also cause a little bit of distortion as well. But it's a good idea for you to know that. They're basically a pair of scissors, robust scissors for metal. Hacksaws, you should know about hacksaws. I haven't actually brought up a thing for this one, so we'll bring it up very, very quickly. A hacksaw and hacksaw blades. Hacksaws are part of what we call the frame saws, and they're called frame saws because they have a frame around them. So this is the frame that we have along here. The blade goes in between, and the blade can be chosen depending on what material. So the more teeth per inch, the better it is at cutting harder materials. So you can get it for cutting plastic. You could even use it on wood, but it's not particularly used for that one. Most hacksaws are used for metal. And you do also have the little junior hacksaws that come on in. And you've seen these and you've used them in the workshop to come in here. And the textbook actually gives the teeth per inch, or TPI, and the material job list. Now I would include that. You need to understand about 14, 18, 24 and 32 TPI, or teeth per inch, and what their average use. So make sure that that's in your notes. I will add it into the bits and pieces. But understanding that the more teeth per inch, so 32 TPI, is thinner metals and also harder metals. So it is also, it's strange because you have to think, you can't have really big chunky teeth and really thin material because then you'll be like dunk, 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 and it jumps over the material as you're trying to cut it. But equally, if it's particularly hard, you're also going to need more teeth per inch in order to cut away that surface and do it far quicker. So you will find that, for example, if you compare a metal blade to a wood blade, the wood blade has far larger teeth and therefore less teeth per inch than the metal blade. And that really is quite an important aspect to it. And let me see if I can see Hacksaw blade. Let's see, close up. So we see anything on there. Oh, yeah. Let's see if we can get a little bit of an image on these ones. Yeah, a bit of it there, but you're not getting a great deal on that one. But you can kind of start to see that they've got quite a lot of the actual teeth in there, rather than just having, you know, the sort of larger teeth that you would find on, say, a wooden blade. There's a good example of it. So that type of blade there, you can see they're a lot finer, and also the pitch and style of the teeth can be quite different. Something like that, for example, has got a slightly different blade to it, a slightly different arrangement of teeth for cutting different materials. Those are hacksaws. Then we go on to hand files. Again, you've used these. The good thing is that we did get into the workshop. Hopefully we may do it at some point in the future. But these different types of files, they're used for different jobs. Now, if you got lucky enough to see the textbook, you will see that we've got flat files, semi-flat, rounded files, or half round, as we would call them. You've then got square, triangular section, bladed ones as well, and they all better for doing certain jobs. I think it would be fairly obvious for you to understand that something which has got a rounded profile, so a round file, is better for doing round profiles, for doing the inside of a curve, whereas something such as a half round or a flat file is better for doing those flatter sections. You can see there's a really good example. You've got the different ones: round, triangular, square, half round and flat. Now, all of these have their own sort of uses. The most important thing to know is you just got to pick the right file for the job. It's no good trying to do a nice flat surface using a round file. It just will not work. Equally, if you're trying to put a lovely curve on it, it's much harder with big fat sort of, as we would call the sort of long, really rough flat files. They're just not going to be up to the job. So I'd like you to just put down bits and pieces about that. Just make sure you mention what each one of those does. It's about you having the revision notes, but you should understand that. The main thing I want you to focus, though, on this particular task is really about taps and dies. And the taps and dies, a tap and die set is like this. And they come in both metric and imperial, or a mixture of the two. This looks very similar to the one that I've actually got. Nice sort of set. And a tap and die, as you've already experienced, allows you to actually put a thread into something or onto something. A tap is where it's going into something. So you will drill a hole out, and then you use this tap on the piece of work. Sorry, not that one actually. Use the tap on the piece of work, and it will then put a thread on the inside of that hole. It's called a tap because it looks like the handle of a tap. You turn it in a similar sort of way, so you're putting it on and then it goes down into the actual hole and cuts the thread. It has very sharp edges. You have to be careful not to put it too deep without backing it back out again, but again, you've experienced that one. And the die is just the reverse. So a die is actually taking a cylinder of metal and use a die to cut that thread on it to make a bolt, in effect. So one is making the receptacle for it, for the hole, for the actual thread, and this one is actually making the bolt. Now, as long as you understand that basic sort of principle, you will understand about taps and dies. The key thing that the exam board wants you to understand, though, is specific tap sizes. Now, I've got a lovely little video that goes over actually how to do it, and I will link in there, and I'll put it onto our theory folder as well, so have a little bit of a look at that. There are other ones out there that talk about it, but your own personal experience, where you've all done it in the room as well, the actual board wishes you to know about some specific metric ones. If you go in and you put in chart, tap, and drill sizes, you will get some quite large charts. These are far too complicated for you to put into it. They often include imperial. They often include different what we call pitch sizes. Because you see here we've got metric coarse tapping drill sizes. And there's different pitches. Now the pitch itself of a bolt is the distance between the threads, so from one thread to another. Now you do need to understand the principle of that, but I don't want you to get too hung up on it. So you can see here you've got an M1 or 1mm sized metric. It's got a pitch of 0.25. You actually use a 0.75 drill to actually drill it out before putting that one in. A 10mm, for example, though, has a 1.5 pitch. It asks you to use an 8.5mm drill, and then therefore you can use, and that creates a 10mm thread. That's actually not a bad chart to have. So if you haven't already got it, that's a good one. You need to know about the M3, the M4, M5, 6, 7, and 8. As long as you've got those, they are fairly happy that you've got all the ones that you need. You can add the other bits and pieces in. It's just so that you've got a reference for that, exactly what you are. And there are, if you look online, you can get magnetic ones that people put in their tool cases. Very, very straightforward. You can find those dead easily. That is really what, there are some other bits and pieces like calipers and etc. that you can have a look at. I'm not going to go into that one today. We'll leave that for another time. I just want you to add those bits in. There will be one more where we talk a little bit more about hand tools and some other processes, but that's just a nice simple one to finish up on. I would like to know as well if you would like a live lesson. Now, I was thinking about doing this one. If you can message me, I was thinking about doing it on Monday instead and actually talking over bits and pieces, how you're doing, if there's any other bits and pieces. Having a live lesson where I say, right, I'd like us all to be in at 9:30 and I will actually be here live talking to you, because we haven't done that yet. I've always done these recorded videos. I just want to know if that's something that you'd like to do. So, ball's in your court. If you'd like to do that, message me, let me know, or just leave a little bit of a note in our little Teams group. Just to say if you think it'd be a nice idea. If there's enough people that are interested in doing it, I will have a little bit of a session where we can talk about certain things. So I might do a live lesson and I will talk over a bit of theory. So it might well be that I have a little bit more of a look into different drawing techniques, or maybe a bit of theory that we haven't covered from the textbook, and we do it as a live lesson, and I'll record it as well for those people that missed. Okay, everyone, hopefully that's all going to be good, and I look forward to seeing your full charts. For those people that haven't done it, please make sure you do all the previous one as well. You know who you are because I've just gone through your names. Take care, everyone. Have a nice weekend, and I'll speak to you soon.